A bounded inequality is referred to as a compound and inequality. And this is one that will look like the following. Okay, actually, let me go back to this unbounded inequality really quickly, because I want to talk about how you can solve this with your calculators also. And so your calculators are designed to solve inequalities. And so we could verify that we have the right answer here by simply typing in solve, enter the inequality exactly as it appears, and then hitting enter. So if I use my calculator here, the algebra tab, F2, choose solve, enter my expression exactly as it appears. So negative 4x plus 3. The less than symbol is right down here. It's the blue button, the second, and then 0 right above the 0. And then type your remaining expression, x minus 2, comma x. Tell the calculator what you want it to solve for, and when you hit enter, it verifies x is greater than 1. And so you can still use your calculators to verify and solve these inequalities. Okay, now, the key to this is you'll most likely be asked to enter your answer in interval notation. Your calculators won't give you interval notation, so even if you solve it with your calculator, you still need to interpret the information and write it in the interval form. All right, let's go back then to these bounded inequalities. And so these compound and inequalities, where the variable is sandwiched in between the two outer extreme numbers. So you see this inequality has three parts, a middle part and then the outer parts. And when you work to solve this, what you need to do is you need to work to isolate your variable in the middle part. And you do this by undoing operations to all the other parts. So as we work to isolate our x, we're going to undo a 5. So we're going to subtract 5 from all parts. Whatever you do to get the middle alone, the middle variable alone, you have to do it to all the parts. So we get negative 8 is less than or equal to 2x, which is less than 2. And then continue to isolate that variable in the middle part. So we're going to divide by 2. Giving us a negative 4 is less than or equal to x, which is less than 1. So here would be our inequality notation. And so once again, just like with unbounded intervals, you have to be able to reinterpret this into the interval notation form. And now it's this sandwiched value. So it has a definite minimal value. The minimum value in this case is negative 4. It has a definite maximum value. It only extends up to but not including 1. And then it's just a matter of, again, figuring out which grouping symbols belong. So negative 4 is included. It has the equal to associated with it. So is that going to be a parentheses or a bracket at negative 4? Bracket. And then the upper limit of 1 has no equal to, so is that going to be included in the set? No, so it'll have a parentheses. So this is what your interval notation would look like for this problem. All right, so if you look at these, and once again, if you wanted to check to see, can you solve this with your calculator, just enter it exactly as it appears. This compound and inequality. So I'm going to go ahead and demonstrate it here. I'll show you what you type in regardless. If you have the right form, it'll give you an answer. So just hit solve, type in the equation exactly as it appears. Now note the inequality. Notice I have this less than or equal to. There's two different ways that you can express that on your calculator. You can do it just like we do when we type something online. So you can hit second 0 to get the less than, then choose the equal to. And then type your middle expression, 2x plus 5, and then less than and then type your last expression, 7, comma, x. And then if you hit enter, again, notice mine says missing a parentheses. That just means that it's not going to calculate it for me. Again, you need the most up-to-date operating system for that. And now there is another way that you can get this less than or equal to symbol to show up. It's not listed anywhere, but if you hit the green diamond and then the less than symbol, so green diamond and then 0, it puts a less than or equal to combined into one symbol for you. And once again, no matter what I do, it's not going to calculate that for me because this doesn't have the updated operating system. Right, so in this problem, whatever you do to isolate the variable in the middle, you have to perform that same set of operations to the outer, the extremes. Okay, so we undo in reverse order of operations. So we're going to add or subtract first. So we subtract a 5 from all parts. Now we can undo the multiplication, so we're going to divide all parts by a -2. Now, since we divided by a negative, what do we have to do to the symbols? And so even on this bounded interval, or this bounded inequality, we still need to flip the symbol if you're multiplying or dividing by a negative. We get x in the middle. -6 over -2 is 3. -10 over -2 is 5. Okay, and so when you're looking at this, and this brings up a couple things. First, the idea that even on these compound inequalities, you do have to flip the symbol. But the other idea is when you write your answers, you need to write your solutions so that the smallest number is written first, the larger number is written last. It needs to go in the same order as a number line. So is 5 to the left of 3 on a number line? So even if I was writing this in inequality notation, I'd need to switch the order. 3 goes first, 5 goes last. Now, the relationship and the properties of the inequality still hold true. So this inequality symbol is going to open to the 5 and point at the x. So open to the 5 and point at the x. Same here. This inequality is going to open to the x and point at the 3. So open to the x, point at the 3. So this would be my inequality notation. And in the interval form, my lower limit of 3, my upper limit of 5. Is 3 included in my set? Has the equal to, so bracket, is 5 included in the set? Also has the equal to, so it's a bracket too. And so that would be the interval notation for that solution.